This is Mr. Long with video lesson 5.3, 5.4, and 5.5. We have quite a bit to cover today, so I'm going to go ahead and go as fast as I can. When you need to, or you get confused or something, feel free to go back and watch that section again. So get your note all set up. Terminating and repeating decimals is actually lesson 5.4, and then ordering integers is 5.3 and 5.5 that I'm going to combine together. So get your paper all set up, and you also will need your packet, page 380. This one right here is what it should look like. I'm going to be referring to that. I'm not going to have you do any of the problems in it or anything, but it's got some really nice graphs and illustrations that I'd like for you to look at. So let's go ahead and get started. Pause it if you need to. So some big vocabulary words. We're going to try to simplify them for you. You need to know these, be familiar with these terms. Whole number is positive number that has no fraction or decimal part. Integers are whole numbers and their opposites. We'll get to that in a second, but what they mean is whole numbers and the negative numbers. Rational numbers are numbers that can be written as a fraction. So let's go ahead and look at this page right here. So rational numbers can be written as a fraction. We said that already. And you'll see this oftentimes for rational numbers, a over b. It just means that, it can be written as a fraction, because a over b would be a fraction, and b cannot equal 0. You can't have a 0 on the bottom of a fraction and have things work right. So here's those terms that we were talking about, and everything as it increases in size means that it's part of the thing that's inside of it. So we'll start from the middle and work our way out. Whole numbers are the numbers that you've been counting since preschool. 1, 2, 3, 4, 5. Whole numbers are like whole pizzas. There's no part of a pizza left. They're whole numbers. Okay, so that's a whole number. No parts to it. That's why we had on this definition over here, no fraction or decimal part. Integers are those whole numbers and their opposites. So that means they are positive numbers and negative numbers, and but there's no decimal or fraction part. So this would be -2, -6, -10. But anything that's an integer, or anything that's a whole number, is also an integer. It's part of that other thing. So you will see the word integers in your chapter titles and on your Alex topics, and what that means is it's going to probably include negative numbers. So think of integers as positive and negative whole numbers. Bigger than that are the rational numbers. Rational numbers are numbers that can be written as fractions. So 1/2, -1/2, 0.8, 5.2, the bar notation over the top of it. Those are all rational numbers. Okay, integers are rational numbers, and whole numbers are also rational numbers. They become more inclusive. We'll talk about that a little bit in class to give you a refresher. So, probably the most important one, like I said, that we're working on this chapter is integers, because it means negative. This means negative numbers. The opposite of a positive is a negative. Okay, so there's some of your terms for today in 5.4. Let's go back and do a couple of, go ahead. I divided lesson 5.4 into two different things. So also on page 380, lesson 5.4, bar notation and negative. Some of you got this in 5th grade, others of you didn't, so we'll go through it as quickly as we can. You use bar notations to show numbers that repeat, using a bar above the digits that repeat, only the digits that repeat too. So if you go back to page 380, it has bar notation definition right here. This is what it'll look like if you divide out a fraction and it comes up with 0.54, 0.54, 0.54. You're not going to write over the whole thing. You're going to write a bar notation over just the numbers that are repeating. Okay, same thing over here. I started dividing out a fraction and it comes out to 0.5, 8, 3, and then it just starts repeating 3, 3, 3. So you go back to that first 3 and put a bar above it, not above the 5 and the 8. not above the 5 and the 8. So we are going to do some of the examples on page 380. Actually, I'm going to give you one that's not on 380 as part of your notes. So let's go ahead and do that for some bar notations. And you're going to love this part of the chapter because it's a lot of dividing. I'm sorry. We'll start off with an easy one. Well, the directions would be something like convert these these fractions into decimals. So 1 over 3, 3 you can't get to a 10, or 3 you can't get to 100, so you're left with no other choice but to divide 3 into 1. Add a decimal, add a couple zeros like we've done, I don't know what that was, chapter 1 or chapter 2, I think. Bring the decimal straight up, 3 goes into 10, 3 times, and you left over with a 1. Bring the 0 down, come out to a 10. 3 goes into 10, 3 times. And as soon as you realize, oh my gosh, that thing's repeating and it's just going to keep on doing the same thing over and over again, you stop, and then you write down the part that repeats and put a bar over it. I'm going back and forth, but it should just be a bar over it. Not a whole bunch of 3s with a bar over the last one, but a bar over the first one. So there's example number 1, pretty easy example. Example number 2 is actually in your book. Yeah, 5. Oh, 11 over 12. That's, or 2 over 11 is what I wanted to do. So 2 over 11, you can't get 11 to anything that will help you with the denominator. I'm going to get rid of part of this. We want to show that it does repeat. So 11 goes into 2. Decimal point, add a couple zeros. 11 goes into 20 once. Divide this out. 11 can't go into 9, so you put a 0 down there. That's where that 0 came from. That goes 8 times. 11 times 8 is 88. It comes out to not enough room. That's what it comes out to. Did I do something wrong? Oh, okay, there it is. Like, it's supposed to start repeating. Why isn't it another 8? So 11 goes into 20 one time, and then you might be going, oh, look, it's going to repeat itself. 1 times 11 is 11, and we subtract, and it's 9 again, just like it was right here. Add a 0, bring it down, and it's a 9 again. So 0.18, 0.18, 0.18, it's just going to be repeating like that forever. So you go back over here, and you put 0.18, and put a line over both the 1 and the 8, because those are the numbers that are repeating. That is called bar notation. All right, sorry, stumbled on that a little bit, but let's go ahead and go on to 5.5. So turn to, in your book, page 388. Let me get there too. Sorry, flip ahead. All right. So comparing and ordering fractions. I'm going to mainly talk from here on this part. So comparing and ordering fraction. So it's nice to see it on a number line like I have right here. So take a look at that number line. You've got the 0 in the middle. Some of you are really familiar with negative numbers. I'm sorry, other people are not, so I got to go through this. So you got the 0 right in the middle. Everything on this side, those are whole positive numbers. They're getting bigger. You know, the bigger the number, the more you have. On this side, the further you go that way, the lower you get. The lower you get. So as you're moving away from 0, it's -1, -2, -3, -4, and those numbers are getting lower. So lesson 5.3 was all about that -5 is smaller than -2 because it's further left on the number line. I thought that was a pretty easy concept to get, so I'm not going to write any separate notes for that. So the further left on the number line, the lower the number. And these things are numbered on the negative side, just like they're on the positive side, except a mirror image of it, right? So if I had -1/2, it would be right here. So I can't get that any thinner. Negative 1/2 would be right there. Positive 1/2 would be here. Negative 3.5 would be halfway in between. Negative 3.5. It's further left than the negative 3 because it's further from 0. All right? So, moving on to page 388. So you're going to love this too. Lots more dividing. And then we'll quickly move on to graphing in the next lesson. So that's a lot more fun. So if you look on page 388 and look at this one, not the first one, we can skip that one. Negative 4 or negative 1.4 is less than, greater to, or equal to negative 1.25. So which one of these is, they're both negative, so which one's further to the left, further away from 0? That means it's smaller. Okay, so 1.4 is further away than 1.25 is, so it is going to be less than. Oh, silly pen's not working on here. Less than. And here it is on a number line. There'd be 0 would be up here. If I was to continue the number line, this is negative 1.2, negative 1.3. So negative 1.5 is right here. Negative 1.40 is right here. It's less than. Okay. Think of temperature. Think of money. You know, I've lost $1.40. My friends lost, $1.25. Who's lost more money? You have. So that's how you do those. When you are faced with ordering them, so that's comparing them. Which one's bigger? Which one's smaller? Look at example number 4 on here. And you have a decimal and you have a fraction. So go back and look at your notes. You got to get common terms. You need to have common terms so that you can compare them. And you have a large skill set to draw from, everything we've done in the class this year. If you don't have to divide the denominator into the numerator, it's okay. That's great. Use that skill that you have, or lots of times you just have to be doing some dividing. So why don't I work this? I'll work this here and then I'll add it to the notes later, so you don't have to watch me write it twice, but they have it all laid out here nicely. So greater than, less than, right? So this is a decimal form, obviously, and the other one is a fraction form. So decimal, fraction. Why that pen's not working today. So the first thing, rename that as a decimal, then graph them on a number line, or if you can visualize it, that's even better. So how do I get 0.51 as a decimal? You divide, and they did it for you over here. But even though it's negative, you follow the same process. 15 goes into 8. And you would start dividing it, and I'm not going to make you watch me divide it, but it would come out to 5.33333333. So that's it right there. So which one is this one is less than, because you see it's not as far away from the 0 as the other one is. So this is less than that. All right. We will practice those a lot in class, but it basically comes down to you get them in common terms. So both decimals. Most of the time it's going to be decimals when you're working with number lines and negative numbers. And then you see which one's farther to the left. Which one is smaller? Which one is bigger? Okay, I think that is it for now. We will practice some more in class tomorrow.